Good day everyone, welcome back. Let's look at this question. Find all angles in this diagram. We have a circle and we have number of angles in here that are given to us, as well as number of angles that are not given to us, and we have to find them. All right, let's get started. Let's look at angle 1. Angle 1, we know that angle 1 is part of this triangle. Let's call this triangle A, B, and C, and ABC is an isosceles triangle because from this point to B and from a center to A, those two lengths, they're the same. There are the two legs of the isosceles triangle. There are the radii. Therefore, angle 1 must be 53 degrees. All right. And the answer, isosceles triangle. Let's look at angle 2. Angle 2 is part of this isosceles triangle ACB, and since we have two of the angles, both are 53 degrees, the base angles 53 degrees and 53 degrees, then whatever is left out of the 180 degrees is angle 2. Remember, the sum of all the interior angles of a triangle is equal to 180. So here we got 106. So let's do the math. 180. And then you'll get 74 degrees. All right, that's angle 2. Now let's look at angle 3. So angle 3 is around the center of the circle, and you can see that right there. So angle 2, 3, and this angle right here, we can call it angle 3 again because these two angles with the tick mark, they're the same according to what we see on the diagram. So we do know that angles at a point, they add up to 360 degrees. We know that. That's one of the properties of the angles at a point. All right, and we do know that two of the angles are the same, and that angle 2, we already have the measure of angle 2. So we have angle 2 is equal to 74 degrees, and we know that angle 3 is equal to another angle 3, the other side. We can call that angle 3. In this case, we can call it angle 3A if you want to. So this guy right here, let's call that angle 3A. All right. So what it is, these two are exactly the same. So what I can write is that we can say angle 2 plus 2 angle 3, they must equal to 360 degrees. Well, we do know angle 2 is 74 degrees. Let's substitute that. So we say 74 degrees plus 2 angle 3. We don't know what the measure of angle 3 is. We're finding it. Equal to 360. We're going to do the math. So 2 times angle 3 is equal to 360. Subtract 74. And what do we have? We have 286 degrees when you subtract 74 from 360, but we don't need 2 times angle 3, we need angle 3. So angle 3, you have to divide 286 degrees by 2, and that would be 143 degrees, and that's the measure of angle 3. Great. So we did a little bit of an algebra there. So here we go, angle 143. Let me change it to color. That's 143 degrees. Angles at a point equal to 360 degrees. That's the reasoning behind it. All right, let's look at angle 5 and angle 4. Well, angle 4 is, let's look at angle 5 first. Angle 5, which is right here, is on the same side of a transversal where you have an angle 72 degrees, and according to the properties, one of the properties of parallel lines is that you have a transversal. So this line here is the transversal all the way through, right? And if you have a line that's called transversal crossing the two parallel lines, and the two tick mark here and there are two parallel lines, then the rule says that these two angles, angle 5, angle 72 degrees, they add up to be 180 degrees. They're supplementary angles. So angle 5 has to be part of 180 degrees minus 72, and in this case will be 100. Now that we have angle 5, so angle 5, now we have 108 is angle 5, and remember the reason is 108 is because these two lines, this one and this one, they're parallel lines, and this line that crosses both of the parallel lines, I call them transversal. And one of the rules of parallel lines with the transversal is that angles on the same side of a transversal add up to 180 degrees, or they are supplementary. So here it is, and that's the reasoning as angle 5. And angle 4 is very easy. The sum of all angles, interior angles of a quadrilateral, and this is a quadrilateral. Let's call this A. So this is A, C, B, and let's call this D and E. So the quadrilaterals CDEB, the sum of all interior angles, they must add up to 360 degrees. And then that's the angle for angle 4. We can find out what that is. We're going to add up all the other angles, subtract away from 360, and then we will get angle 4. So here is the math for that. And when you have the math written, 360 minus 143 for angle 3, minus 108 for angle 5, and then minus angle 72 degrees, the final answer is 37 degrees. So here we are. We just completely answered all these questions with the reasoning beside it on each of these questions. All right. Have a fantastic day. Until next time.